Okay. You remember like the lambda expression syntax and the benefits of going with the lambda expressions, a basic idea, or you have any questions on that?
Yeah, can we have the revision session today?
Yeah, sure. Okay. Yeah. Janaki, you have any topics you wanted to be discussed today?
That input output stream, that one you have just.
Are you handling it?
Yeah, overview is fine.
Okay. Yeah. And any other topics?
Then that comparable and comparator. Actually, you said the difference, but like for sorting we will use, but not in depth actually. But
Comparable and comparator.
comparator, yeah.
Okay. Only these two you have clarifications, or you want some other topic to be?
So now only these two.
Sorry.
Only these two from here.
Okay. And Kirba, you mentioned about something on threading, right?
My questions were in collections
Okay, collections.
and the sorting algorithms. Like for example, if you're going to sort
Mm-hmm.
a set of number in ascending or descending order, which data structure to go. So
Okay.
those things and time complexity and space complexity for each data structure. For example, if you take bubble sort, if you do with the list, or if you go with binary tree, what's the difference? Like that. And
Okay. Yeah, sure.
the threading, you can, if you have some time, you can just give a refresh.
Yeah, okay. And so sorting algorithms and collections kind of on time and space. Okay. Okay. Let me start with collections and I'll go with comparator, then I'll go with sorting, then I finally come with IO. So So on the collections part, this is classified into two things. So three things. So you remember those three names?
Can you
We'll
repeat the
have it
question,
as more
please?
of an interactive session so that we'll see how we remember the points, whatever we learned.
Yeah, can you please repeat the question?
Like, what are the three categories of collection? So what is actually collection? Maybe we can start with that.
So collection, so we use collections to handle complex data, which we cannot handle using primitive data types.
Okay. So why basically collection? It's like instead of handling the primitive types, we'll be moving out with the object structure. And also this collection is like a group of operations can be performed, can be any sorting or searching or collecting a group of information or like basically to collect the data. So all these kind of aggregate operations can be performed on your objects through your collections. So that is the thing, we go for collection. That is the main criteria why we prefer collections, because when you're using any primitive or any kind of primitive data types, you might not be so efficient on handling a large amount of data set on it. So you might fail. And when it comes to object oriented programming, we might again not sync up with the primitive data types and the object concept together. So that is the reason we prefer to go with collections. So on this group of operations, collections interface, we actually so our topmost class in Java is, do you remember the topmost class in Java?
Object is.
Yeah, so object is our topmost class, right? So which comes from our Java land. And and that section, we have something called as an abstract collection. Okay. So so you know the concept of abstraction, right? What do we do on abstraction?
So we just show what is implemented and we hide how it is implemented.
Yeah, the same thing. So this is our actual topmost class in our collection class, okay, in the abstract collection. And now this collection is again classified into our three categories: the list, set, queue, map. All these will be following in this chain. So we have first, let's go with the list part. So we again have the topmost class called abstract list. Okay. So let's first finish on the list one. So the abstract list. So this will be your topmost class, but we usually use list either as array list or linked list, which again fall into these categories. This is the child of the abstract list. So under this, you have again array list. And you know something, you would have learned something as vector, but you never used it, and only in threading we heard thought of to use that. So which is vector. Okay. And on under this part, there's one more thing called as sequential list, which is nothing but linked list. So you can either call it as abstract sequential list, or you can just call it as linked list. So this is the thing we have under our abstract list class. So this would be the hierarchy. So the topmost is object. So we have a class called abstract collection, under which this will be the abstract list, array list, linked list. So if I go to here and if I create a list, so you see something called abstract list, right? So this abstract list is nothing but which is coming from your abstract collection. So this is nothing but from your collection back again, which is an interface, which again extends your IEEE. Okay, so basically all your operations which you perform, like a group of activities, are coming from a parent class called IEEE. So internally, when you use the child classes like list or map or set, they all fall into these hierarchy. So this is one hierarchy which we are trying to understand. Post this, I'll let you know how the map, on how the abstract collection list is actually formed. But right now, this would be the actual structure for your list part. Any questions so far in the hierarchy of this list part? We'll see the usage now again. But till now, any questions on hierarchy?
Yes. Okay.
Okay. So now, so usually we never go with abstract list because they're indirectly we are using the abstract collection on top of the parent class, which actually gives you the basic methods which we usually check, like whether the element is present in your list, or where to check this a list is present or like is empty or is it full, or you wanted to know those things, or the size of the list. Or if you want to add any elements, the basic operations, add, remove, all the CRUD operations will be coming from your abstract collection, which is nothing but from your top class called IEEE. And here you can do all the operations which you want to do on your data set, which you want to manipulate and do any kind of manipulation. Then you can use this IEEE interface. And this collection is again something which is your main parent class to do your CRUD operations on your list. For that, so these are the two interfaces which we depend on. One is collection interface. Another one is IEEE interface, where the IEEE interface helps you to perform your manipulation activities, whereas this interface is kind of does the basic check, like whether it is you want to add the data or remove the data, or you want to update any data, or if you wanted to check the data set is present or empty. Basic criteria checks can be done from your collection interface. So this is common for all the child elements like list, set, map, and all the sub-child elements like array list, linked list, hash set, tree set, hash map, tree map. For all the things, this is again a basic structure. On top of that, for each specific child, you have an additional methods and additional functionalities added on. So this is the hierarchy for it. So you know the two things like array list and linked list. So what points you remember under array list and linked list? We'll first cover up this side. So why do we need array list and why do we need linked list? We'll see these points now, and also the time complexity and space complexity over here. So yeah, can someone tell me? Meanwhile, I'll just take one more document which I have.
So array list is a single linked list. So we can traverse one way. We can go from left to right, but not right to left. Linked list is a double linked list. So we can traverse in both the directions.
Okay, okay. That is a basic understanding of single linked list and double linked list. Okay, apart from that, any other points you have?
Any other point other than this?
Sorry?
These are the only things that are in my mind for now.
Okay, and Janaki, you have any points on that?
No, Sneha.
You tell me what points you remember under array list and linked list.
Array list can be empty or even it cannot be empty actually, but linked list is not the case. We should have some data
Sorry?
and address. Array list, it can be empty, but linked list, it should have the data and the address of the next element also.
Okay.
In array, you said you will have data and the address of the next element will be there, whereas in linked list, data with the address of previous and next element will be there in the linked list.
Okay. What are additional things you can do with array list and linked list? Like any other differences?
Like we can add one element or even the group element we can do in array. Then sort can be done based on the index.
Okay.
Then one more thing what I remember is like you said something like it will expand during runtime. So I'm not sure whether it is array or
No, the expansion is a different thing. That is on your collection. There is difference between array and array list.
Oh, okay.
Okay. So let's first figure out the basic thing. The array list and linked list will fall into a single threaded environment. Basically, if you're not using any threading concept, if you're not going with multi-threaded environment. So you remember what is multi-threading? Anyone can
Yes,
say?
Neha.
So you remember multi-threading. So when you wanted to do a parallel processing, then you are in need of multiple activities together to be performed, where your array list and linked list are not that efficient to be working on a multi-threaded environment. In that case, if you want to achieve all the features of your list through in a multi-threaded environment, we prefer to go with vector. Apart from that, all the features for all these three childs for your abstract list are very common. So the basic thing what we do in an array list, the first thing is we add the elements, right? The second thing, we get the elements from it, and then we update it, okay, and we delete it, and then we check the size part, and then we do the empty check. Everything is done. Okay. So before going to the array list, you remember array? What is an array?
Yeah.
So why are we going from array to array list? Because you can even create an object array, or you can create your student array. But why are we going with array list? What is the main benefit of going with array and array list?
So array list is growable at any point of time.
Yeah, so the list is growable. So here, this is the main thing. So the array is like whenever you create an array object equal to new array or any dynamic array, the size is fixed. The size is actually fixed. Okay. You can't expand it. If you want to expand, you have to again reset your array where the entire copy is getting created. So which is like known to the user that you're actually having a size of 5, but now you wanted an array size of 10. So you have to recreate the object or reassign something. So what happens, the entire data set, whichever is created in the backend, for example, array A1 equal to new array of 5. This is what I gave. So let's take it as string array. So in that case, my object can hold only the positions of 5 and not more than that. So the length is only 5. But in case on some scenario, I'm trying to expand the size of array from 5 to 10. So in that case, explicitly the user is responsible to increase the size, like basically the developer, and back in the system is not very easily have the control to expand the system. So it has to recreate one more array with 10, copy the elements from back end from the 5 elements and have it everything in the 10 positioned array pot. So which is like every time the backend JVM is having one more work added on top of it. So additional load is getting created. So to reduce this part from fixed to dynamic, we have something called as list. So if you wanted to expand your list on runtime and you don't want to keep it a static value for your object, which can be growable anytime, and you can't decide the size immediately, then you can prefer to go with the list part. So this is the main difference between your array and array list. Okay. So any other differences you remember on array and array list? Any other operations? So what if I need to add an element to an array? Where the data gets added if I want to insert something?
Add at the last or
yeah, at the last, right? So every time it has to, the basic thing both in array and array list, the one common feature is it fetches all your data based on indexing. Even if you go for array or even go for the list, the indexing is the main thing. Based on the positions from array of 0 or array of 1 to the list of 0 or list of 1, the data is getting fetched based only on the index. Okay. Internally, the list also works similar to array. The only thing is the feature, whatever is happening on the growable size, the backend creation or recreation part, resizing the entire list is not known explicitly, where the system can be more flexible to take care of that compared to array. But if you're ensuring that my size is very fixed, I have to perform only this, and I want a performativity kind of data set. I have I have 100 records and I need immediately the first record. Then I prefer you to go for array. But if you're not sure like whether you have 100 data set or 1 million data set, then I prefer you to go for list. So if you want your data set to be more performativity wise, then and you are pretty sure about your data set count and volume and everything, then you can go with array blindly. But if you're not sure and your data set is something which grows dynamically, then you should go with the list part. This is the one more difference between array and array list, the performativity part. So apart from adding, deletion, everything is same thing. So what happens whenever you add a data in your array? So if I have an array of size like this, and let's say like we have some few positions here. So let's just say 10. So if I'm deleting some element in between 0 and 10, let's take I'm deleting an element here with position 5. So what happens in the backend system if I'm deleting an element from 5? Will that 5 element will be blank, or the elements from on the right of that 5 will be reiterated and pushed to the before position? Like how does it actually happen?
So the index 5 will be blank.
Index 5 will be blank?
Yeah. Array, right?
Yeah, in array. Okay, so the same thing if I'm doing in a list, what happens? Will I have still the position 5 as null, or will I have a position 5 with the next element data?
Next element data.
Yeah. So is it a benefit for us or is it a hindrance for us?
A benefit for us.
Yeah, that is also one more difference why we prefer to go for our list feature. So any other points you remember on array and list?
So this iterator class can just
okay. So when you wanted to fetch any data or you want to manipulate your data set of array or list, what we do is on your array, you have to use a normal for loop, right? You have to do a normal for loop or normal while loop, the basic conditional loops, you use it, and then you get your data. And then you update everything by based on the positions. So if you want to update a of 5 equal to a of 6, then you have to iterate and move all your elements from a of 6 to a of 5. And then you have to do everything manually. But in our interfaces, like basically in the collection, everything is being provided from our collection interface, where explicitly we have a method called iterator. Okay. So this is coming from your iterable interface. So what happens, any type of collection can be iterated, which acts similar to your for loop. And from on top of that, since the list has both next element and the previous element, if it's double links, if it's a single link, you have the next element. So we'll be checking whether my iterator has the next element. If it is present, I'll fetch that next element and use it based on the data set. So this is something like the internal logic, the orchestration of how your iterator has to work has been predefined. Whereas in your array part, it is something the developer has to do on that place where he needs the which kind of data to be extracted from. So this would be the iterator iterable interface part. So this is one advantage which is common for all your child classes for set, map, and then list. So any other differences you remember on array and list?
So there is one for enhanced for loop which we can use for the iteration purpose for collections. And
the enhanced for loop can be even used for array.
so I was saying, I remember like if you use iterator function, then we can dynamically modify the values. But
Yeah.
by using,
So if I have something like internally, all your data set of your list, every list will have the data element and the next element which holds your address of the next node. Basically a node. Node is nothing but which has data and the address. So here you'll have every element data which internally acts as an object array, and then you have this next element which holds the position, like basically address of the element. So whenever you're trying to iterate, internally the list will be compressed or expanded, and you don't need to worry about how it is happening in the backend. It will take care of. But what is happening internally is it is actually recreating one more copy of that entire list set, which looks similar to your array structure, and it just positions, the data positions is getting altered. That's it. But that is completely taken care by our JVM machine itself using the relevant operations. So you don't need to worry about whether the size is getting resized or it is getting expanded or it is getting compressed. You don't need to worry about it. This list, this entire architecture, the data structure of this list will be taken care. So the resizing, restructuring, everything will be taken care by the backend system. Based on the use cases which you work on, like if you are very sure that I want a very fast result, okay, I have a fixed value set, and I know all the operations can be even performed from an array, then go blindly with an array if you're focusing only on performance. But apart from that, if you're focusing on fetching the data in a very faster way, then I prefer to go for list, because you can just give dot get method, you'll get the data. Whereas in object array, what happens, you have to do an iteration. On iteration, you have to pass the I value and get it. Okay, and if you want to get any kind of even then it is an indexing based, even then you have to pass the position there. So the main advantage of list is it is so user friendly, and if you don't have a fixed size of data, then you can go with the list part. Apart from that, all the features are common for both array and array list. Any not array list, any kind of list. So this is the main reason. So if you wanted to know the space complexity and time complexity on the array and array list, that would be very easy for you to identify, because both are working on the indexing part. Okay, so how do we calculate the space complexity and time complexity? You remember the basic which we learned earlier, like the space complexity is identified on few things and time complexity is identified based on the manipulation which we do on that. So for example, if I have an array of size 10 and I need to collect all the array elements and sum them up, this is my use case. So what would be the space complexity for this use case?
space complexity would be like order of one, right? It's a fixed size.
Yeah, it's a fixed space. So it will be like O of 1. Okay, then
What's an expression? Time complexity.
sorry. What if for the array part?
Array, right? Space complexity.
Mm-hmm. Yeah, you can tell me on the time complexity for the array and array list for the use case which I mentioned.
So to get, we are going to mix of index. So array, we can just mention the index.
So you remember the notations which we learned, the three kind of notations for our algorithms complexity measuring.
Omega of 1, omega of n, omega of n square.
No, not that one. There are three things, right? Theta, omega, and the other one is pi symbol. What does these three represent?
Repeat the third symbol, theta, omega. The third one is?
No, you remember the three ones which I have mentioned earlier on the algorithms part?
One is for best case scenario, worst case scenario. It's general case.
I think I mentioned big O notation. There's some difference I mentioned, right? I completely forgot like what did I say that one.
You mentioned O, omega, and theta, which is for upper bound, lower bound, average bound, something you mentioned.
Yeah, exactly. The upper bound and lower bound. But for that part, we have seen this like basically like the O of 1 is the fixed one. Okay. And till O of n, you have one more range. Okay. And you have O of n square. Okay. And this goes still with O of log n. So where do this upper bound come? Where the worst case, like basically best, worst, and middle? How we differentiate it?
So order of log n comes before order of n, right?
Yeah, okay. But why? How do we range it? Why do we say the log n is better than the n?
So basically, n is n times where, like for example, if we have a for loop, if we have, if you're going to iterate for n times, then the order of complexity is O of n, and if it's going to be less than n, somewhere between order of 1 and order of n, then we like come to order of log n, I guess. So log n is in between order of 1 and order of n.
Okay, so how do we say that which one is best? The best case and worst case, right? How do we define the best case and worst case?
Example, if you're going to search in an array, for example, you're going to search for a particular number in an array of size 10. So the best case would be the number for which you are searching for lies in the first index. So that would be the best case, and the worst case is the last index.
Okay.
Yeah, that's how we define best case and worst case, right?
Okay. So Janaki, what about you? Like, how did you remember?
The time complexity should be minimum. That will be the best case.
Okay.
And space complexity also. I remember only time complexity. Like if it is lower, then that is the best case.
Okay. Is this my ordering right or it's wrong?
I think it's wrong. Order of 1 followed by order of
this is not in the increasing order, right?
Yeah, it's not in the
So the increasing order forms with O of 1, log n, Then
N.
it would be
Order of
square root
n.
of n.
Order of n.
Then it comes with n log n. Sorry, n. And then it comes with n log n. And then that becomes a n square.
2 power n.
Then it goes with n power n. So this would be the ordering. So the O of 1 is like static, O of n is again in between, O of n power n is in the last one. So this would be the increasing order. So how can I say which is the best case here and the worst case here? Like how do you compare here? Which is best and worst?
Order of 1 is best. Order of n power n is
So
worst.
that falls into best case.
Yeah, order of 1 is the best case.
So how we are saying in the best case? Because it has the less execution time. So O of 1, and so all these things, right? O of 1 till O of n, like this particular piece will all come with a less execution time because it is like, it's not actually n value, right? It's square root of n. So all those values will be very minimal. So if I say example 4, then the square root of 4 is 2. So my range, if n is 4, then my values before that will all come into a less execution time frame. 4 would be like average case. And then this n to n power n would again get into the worst case scenario. So basically the less execution time is one of the main thing which we look on. And the average case is just function of n, just whatever it is, function of n. This is like n into any kind of function, but this is always a static thing. So the best is will always O of 1, but sometimes for few scenarios, any kind of algorithms like sorting or any kind of data structures which we work on, we might get into log n, or sometimes we may also come and end up with O of n. Okay, so this is the time complexity we actually measure up. So how do we do space complexity? So like we took an example of sum of n natural numbers from an array list or an array. So what are the attributes or any kind of space elements you use for that? How do you fetch it? How do you calculate your n number of values?
So we are going to get this number dynamically, right? Yeah.
So you have an array, right? So array is again a input for you. So I need some array here, okay? And then on top of that, what are the spaces you need to do the sum calculation?
We need some variable.
Yeah, wherever you accumulate all the data set, you need one constant where you actually do this. So let me take total. That will be one more variable. Okay. So yeah, so that is like one of the space where your data is getting holded on. What are the things you need to do this?
Maybe one more loop control variable.
So we need a conditional loop, right, to get each element and perform an activity on addition of these things. So you need a for loop or a while loop, any kind of loop where that is getting iterated for n number of times. Basically, the size of your array times, you will get it iterated and you fetch every element and you accumulate to the variable total. So you need a loop in between, right? So the loop, any kind of loop, which has been iterated for n times. So what would be the execution time for that loop? Let's say if my for loop is I equal to 0 and I less than array of size, okay, array size, and then I plus plus. So if this is my case where I'm going to fetch every time, what would be the time complexity or space complexity for this particular flow? So what will be the what is I equal to 0? It is O of 1. And what is this I less than array size? What is the contribution it has? Because array is just n, but every time it is getting iterated for n times, like whatever size, if I have size of 10 elements, then this condition will be iterated for 10 plus 1 or 10 minus 1 situation. And this is again a constant, right? Where this is getting condition like if you have 10 elements, then 10 times this value has to be performed. So 10 plus 1, 11, 11 plus 1, 12. So for how many elements are you have in it, that many times it has to perform. So in that case, I equal to 0 has a constant time and I less than array of size that has n plus 1 of time. And then the I plus plus, which is n times. So the maximum of all these three for loops is ending up with a condition of n plus 1 space. This is what it is actually happening here, n plus 1. So for your time complexity. So now in terms of space complexity, you need one array You need one total attribute and you need an indexing for that purpose. So the overall constant, will it be ending with a constant or O of n for space?
Order of n.
Order of
N.
n, because this array is basically a list of elements, right? So this would be with n. All the total, all the I value iterations, whatever do additionally on top of it is just constantly constant space. So you don't need anything explicitly. So it's all constant space. So maximum of all these variables, the thing which is happening is n. So the space complexity would be determined like big O notation of n. Okay. So this is the way we use space comp. So basically space complexity is like how much memory you use to do such kind of problem solving or any kind of operation at the end. That is what the space complexity comes up. But the same space complexity has to like in the lesser execution time, if you are looking for, then the time complexity pitches in. So this is the two differences we have seen so far. Okay. But the representation of this O of n, this is nothing but big O notation. Apart from this big O notation, what other notations do we learn? Have we learned? So the big O notation is basically the upper bound of function. Okay. And there's one more thing which is in the lower bound. And the other one would be on the average bound. Okay. So we represent this lower bound in something called as a pi. Okay. Pi symbol or like a sigma symbol. Okay. I don't know how to represent here. So I can just show you over here. How does that look? This looks like this, a kind of sigma or kind of pi. So not even pi, it's kind of sigma representation. And the other one, the average representation would be in the form of theta. Okay, so we never go for this theta representation or the sigma kind of thing. We always prefer to go with the upper bound of function. That is the big O notation. We always look for the upper bound, which is like big O notation. So most of our time complexity and space complexity would be represented as O of O of O of. Any queries so far on the time and space complexity? Kirba and Janaki.
No, Sneha.
Sorry?
That is clear. This part is clear.
It's clear, right? Okay.
Yeah.
Oh, yes.
Okay. So now you know the difference of array and list. You know the basic difference. We haven't seen anything on coding so far. The basic differences. And then we'll see the time complexity and space complexity for each operation right now. Can we join the other invite?
Okay.
Okay, Sneha.
Yeah, thank you.